Hello folks, and here's a pretty solid way of fixing T1 or T0 sensor issues on an AnyCubic Mega X or Mega S or most of the AnyCubic printers that are out there. So I've been struggling, it's been driving me up the wall. I've got 4 of these things and I run them pretty hard, pretty much 24/7. And sadly, some of them just sort of stop halfway through a print, and I'm sitting there sort of scratching my head saying, why is it stopped? And it says T0 sensor problem. I get my multimeter and I check out what the problem is, and actually the resistance of both the heater and the sensor in the print head are actually looking pretty good. So let me show you how to overhaul the print head and get everything sorted so that you won't have this problem again in the future. And actually the best way that I've found of fixing it is removing that connector completely. So what I'm doing here is I'm just getting the print head in a position on the printer where we can work on it a little bit easier. So I'm just raising it up the platform. And then what we're going to do is go ahead and remove all of the connectors from the bottom of the PCB, the connector from the top of the PCB, which as you can see has been removed already. And then we're going to get an Allen wrench, get in there and start getting that PCB out of place. Then we will remove the connector from the PCB, and I'll show you how to do that. I looked at this and I thought, oh yeah, okay, I can still see sort of reciprocal burned oxidized connectors in there. And the reason why this happens is they're driving 12 volts at a number of amps, and the print head's always moving, so it gets a little bit dodgy over a space of time. I'll get my solder pump and I'll start working on that PCB and start trying to desolder all the connectors and pull that connector out. It's actually going to be a nightmare to do it this way, and suddenly I realized there's a much easier way to do it than trying to desolder all of these connectors, and that is by getting a screwdriver and putting it behind the connector that's on the PCB and gently wrenching the plastic housing off the board whilst leaving all of the pins in place and soldered. And then all you have to do is remove the pins with a soldering iron. And this is so much easier than trying to remove a connector that's ultimately faulty with oxidized pins. The next part of the mission is the rewiring, and the key thing here is to make sure that when you do the rewiring you don't mix up the wires. There's quite a lot of wires, and sadly there's quite a lot of wires that are the same colour. So I chose to do this one by one. Obviously I'd made sure that all of the plated through holes in the PCB were very clean and clear, and then what I started to do was resolder all of these cables to it. You're going to want to take your time over this. Do it properly, get some decent solder connections in there. And the other thing that I noticed is that because the cables had been carrying quite a lot of heavy current, that some of the actual cables themselves were just a little bit messy inside, so the solder didn't take very well. So you know, don't be shy to cut a good inch of wire away from the connector there. So once that cable is all soldered in place and you're happy with it, obviously make sure you check it over with a pair of glasses, with a microscope or a pair of glasses. Next thing you're going to want to do is make sure that you've definitely got your pin connections correct. So I compared it to the original connector, and then I proceeded to start reinstalling that PCB after having wrapped it in a plentiful amounts of electrical tape, because that's what we do on this channel. I then decided to start putting the PCB back in place. It's only held in by 3 little M3, M4 hex heads, no worries at all. And ultimately what this is going to do is it's just going to take away a point of failure, and that connector, sadly, on the AnyCubic, after a period of heavy usage, that connector definitely becomes a point of failure. So what I'm doing now is I'm just rewrapping that cable and I'm getting it secured in place. And again, make sure that cable is very well secured in place. You don't want that cable moving left and right. It's going to stress and fracture those joints eventually, and you're going to end up with the same problem that you had. The next thing, obviously, is make sure that you give it a good old slide from right to left, or whichever way round you prefer, left to right, and check that you're not fatiguing those wires by moving them when the print head's moving, because that print head does an awful lot of moving. And there we have it, all bolted in nicely, slidey, and we can see that those pins aren't moving, those cables aren't moving, so we're not stressing those cables. So next mission, obviously, is plug in the hot end and have a look at your temperature and see what's happening. And as we can see here, we've got temperature increasing. We don't have the TI sensor problem reported by the AnyCubic anymore. I'm really happy to report that this looks like it's been a successful mission. Let's get the printer started and let's go ahead and print something. So guys, thanks ever so much for watching. As always, make sure you give us a good old thumbs up and we'll catch you in the next video. Take care, have a wonderful, wonderful weekend. Don't forget to subscribe if you haven't already. Cheers and beers, folks. Bye for now.